Hi everybody, today we are talking about 8.6 exponential growth and decay. So exponential growth and decay is going to cover three different equations for us to create our own blah, blah, blah. 3, 2, 1. Hi everybody, 8.6 exponential growth and decay is what we are talking about today. We're going to talk about three different functions that we can use to write equations about different situations involving either the growth or decay of an amount. So the first one is going to be just basic exponential growth. Our format for that function is y equals a parentheses 1 plus r close parentheses t, where y represents our final amount, a represents the initial amount. That'd be like our starting amount. R is representing the rate of change as a decimal, and it's going to be a decimal between 0 and 1. So we might be given a percentage and we're going to need to change it into a decimal. We'll talk about that. And then T represents time. And that time could be months, days, weeks. It just depends on the stipulations of the question we're looking at. So for example 1, it says the number of purchases in millions made on a website can be represented by the equation y equals 25 parentheses 1.13 close parentheses exponent of t, where t is the number of years after 2014. And this just wants us to interpret the parameters. We're not solving for anything. We're just identifying what all of the pieces are. So I'm going to rewrite my equation. So we have y equals 25 parentheses 1.13 close parentheses t. Now we know t is going to be time, and it seems to be in years. Now looking at the chart above, we know that the first number that we see, 25, is going to be our initial amount. So that's our starting amount. And then looking at the parentheses, our parentheses are supposed to be 1 plus r. So this is showing us 1 plus 0.13 or 0.13. That 0.13 is our growth rate as a decimal. But sometimes we are going to want to express that in a percentage, or it's going to be given to us in a percentage. So we need to know how to toggle between decimals and percents and vice versa. So to convert the decimal to a percent, we are going to take that decimal of 0.13 and we are going to move the decimal over to the right 2 places. So this gives us a percentage of 13%. 13%. So that is what this equation is representing. Now we are going to attempt to write our own. So in example 2, it says, in 2013, the town of Flat Creek had a population of about 280,000 and a growth rate of 0.85% per year. So we want to identify all of our pieces of information. We have our initial amount, which is 280,000. That's our A. Our growth rate is at 0.85. So that's our rate, and it looks like a decimal, but it still has a percentage sign. So I need to actually turn that even more into a decimal. So we're going to go from a percent to a decimal. So we're going to do the opposite of what we just did. So we have a percentage of 0.85. We are going to take that decimal and slide it to the left 2 times. This gives us a decimal for our rate of 0.0085. So that is going to be our rate. We moved the decimal left 2 times instead of right 2 times. So our equation is going to say y equals 280,000 per parentheses 1 plus our rate of 0.0085 close parentheses t for time. So that is our equation. Part B of this question is asking us what the population will be in the year 2023. Well, our initial amount, our starting time, is 2013. So they want us to do the year 2023. So we need to figure out how many years that has been to find out t. So that is 10 years. You can just subtract them. So t is going to be equal to 10. So I'm going to take that 10 and plug it into my equation. So y equals 280,000, parentheses 1. And you can say 1 plus, or just go ahead and put 1.0085, close parentheses. And again, that t, we're going to replace that t with 10. And we can do that in our calculator. Move where that went. There we go. So we are going to have 280,000, 1.0085, and 10 as our exponent. So you just have to type this into the calculator from here. Calculator. And since we're talking about people, we're going to round it to the nearest whole person. That just makes sense. And so when we type this into our calculator, the value for y, which is how many people after 10 years, is going to be 304,731 people.